Hello everyone. Today let's look into type hinting and static analysis. Right. So as we all know, right? So Python is a dynamically typed language. That means all your input values by default during compile time does not check for its type. So let's say we talk about one method that accept a integer as a parameter, but we can pass a string value, or the method accepts string as a parameter, we can pass a float value, decimal value. So it does not throw error during the compile time, only during the runtime it throws error. While this has its own advantages, when you write a small program, we don't want to worry about all the syntaxes and all. But as the application grow, when you write a program which is a bigger landscape, then when we pass the data from various method, from one method to another method to another method, it gradually get too complex. And sometimes one wrong value pass into one of the method which cascade down to subsequently other method, create lot of issues. Okay, so that's the reason if you see any other languages like C Sharp, as you use the VS Code or use the Visual Studio, as you write the code, we see the compiler warning or the editor warnings. Similarly, when you compile the application, we see the compile time warning if the type mismatch is there, right? So something similar Python don't have from the beginning, right? So only in Python 3.5, Python has started supporting the type hinting. So what do you mean by type hinting? So type hinting will some syntax added to Python code which will tell the editor what is the expected type. So editor can understand and throw similar kind of a error or warning when you as you type in the code. So then we need to have some kind of a application or some kind of a plugin that actually execute your code against those warning or against the type checks and show us the report, right? And then as part of all this parameter, gradually there are a lot of improvements happen. We'll go through what has changed in Python 3.8 to 3.9 to Python 3.10, and there are a lot of improvement happen so that it feel more natural to use this type hinting. So let's go through it, and I think as you more use the type hinting, you will find this by default comes naturally to you as you write your code, right? Okay, so let's see. So first thing, right, as you start writing the type hinting or any Python code, provide a type so that Visual Code or any of your editor can understand what exactly this Python compiler or Python code is trying to execute or trying to pass the value, or so that it can show the respective error and warning. So there are three different things we need to recall. Okay, so there are three different items we need to remember. First item is, let's say, how do I integrate my type checking as part of a continuous integration process so I can arrest it as part of my code check-in or the build package creation. We should not wait for to identify this as a runtime. So in that case, MyPy is a Python package which you can install and run our application code against it, so it can identify all the errors that failed the static code analysis and throw us the error. Now, similarly, let's say as you write the code, right, in the VS Code or in any of your editor, it's always beneficial to see the error upfront as you write in the code. So that's where PyWrite or Pylance comes handy. So VS Code by default comes with the Pylance package. So that means if you install Python, and the by default Pylance package also will get installed. And once you start writing the VS Code, you will see Visual Studio also will tell us what kind of error is there, or if any type hinting or we are passing a wrong value as input parameter, it will highlight them in red. So during the coding time itself, developer can correct the error. Okay, so now how do we configure all the item, right? And moreover, let's say like Visual Studio, we have the static code analysis rules. You can see whether it will be error or it will be a warning, or what kind of different level of error would be there. Similarly, Python supports a file called TOML file, where you can define all the tool level configuration. So you can define, let's say, tool.mypy, and what are the different let's say parameters are there. For example, if you give street equal to false, then the basic syntax errors Python will ignore it. okay, or the mypy will ignore it. But if I give a strict equal to true, so it will be more stricter, right? We'll try to see some of the example with the strict equal to true and false, how is the response. Similarly, you can provide any specific override. For example, in general, I'll say strict equal to false, but for specific namespace or specific module, we can say strict equal to true. So then when mypy will execute the application against specific package, it will be more stricter. So you usually this use this strict more in case of our, let's say, the core packages, or we get a reusable packages. We want to avoid all the compile time errors and make it bug free. We use strict equal to true. So now let's go back to Visual Studio. We'll try to install the mypy package. We'll try to run it against some of the code and see some error before we go into what are the different type of type hinting supported by. So let's say we'll start with first, let's say I've created already some of the code. For example, if we see this particular code, I have two methods. One is summarize test and one is summarize. Both accept exact same parameter, the string value as a text and max token as an integer. So now what I'll do, I'll first run, execute both the code, right? I'll pass the summarize test and summarize. Now if you see here, whenever I pass as a integer value in place of whether is expected is a string type, I see a error in VS Code, this red underline, right? So but it does not stop us from executing the code. For example, if I just run this python the test py, so I can still see the response out, so it does not give any error. So this is one thing we need to remember. So python type hinting is for editors or your compile time check if I use the mypy packages, but python runtime is still dynamically typed, right? So though VS Code highlight this as an error, it does not stop us from running the program, and until unless we are using it to or we are trying to use some of the method which actually expect it as string type, then it will fail. For example, right, so in the summarize I try to use a length, okay, and the length method is only applicable for a string, not a numeric type. So for the summarize, if I now pass a, let's say, integer type and I run the program, so you'll see error. Okay, error says the integer has no length method, right? So that's how python only during your runtime it identify through the error, but during the compile time it does not throw the error. Even type hinting highlight this as error. So then how do we let's say do as part of our regular check-in? If you are using an editor like VS Code, pylance comes handy, right? It will automatically identify underscore as error. But python has a package mypy. So let's first install the mypy package, and then we'll try to execute the code against the mypy. So the mypy package is installed, so you can run mypy and the application name, and when I run it, so it throws error, right? The three different errors are there, type hinting error. So first thing is on line number 12. If you see, if this particular method, this variable text is there but the body is empty, so it's not being used. Similarly, there is a second method, argument to summarize text is incompatible type, integer to string, and similarly the third one, right? So that's how mypy comes handy. We usually include the mypy as part of our continuous integration pipeline. So if there are any error, it will fail the build. So in that way we can avoid the errors being identified at the runtime, so you can catch during the compile time. Okay, so now let's go back to PPT. We'll go through some of the type hinting types that supported in Python. Then we come back to VS Code and try out certain example to. Okay, so now we see earlier Python before 3.5, it does not support the type hinting. That means I cannot define text as a type of string or max token as a type of integer. We used to just pass the value as text and max token. So in that way Python, it was purely dynamically typed, but that's get a lot of runtime issues. So from the starting from 3.5 onwards, Python introduced the type hinting, so I can specify the variable or the return type, what kind of what kind of input or output this particular method is expecting, right? Or whenever we define a variable, we can specify what is the type of the variable. Okay, so now in Python 3. up to 3.8, so there are certain types are there, for example list, dictionary and others. Up to Python 3.8, so we have to import from a package called typing. From the typing module or package we import the different type, we use it. But starting from Python 3.9 onwards, these all are built in into the default Python library, so you don't have to import any additional package for to use the type hinting for list, dictionary and other type. Okay, so similarly let's go to the next type before we go to the application code. So similarly, there are different types are there. For instance, we define name as a string type, or in the Python starting 3.10 onwards, Python has a the string, and this is called union, string union none. That means the return type can be a string or a none type. So this is equivalent to C sharp's nullable string. Okay, C is any type as a nullable type. Before Python 3.10, we used to have optional as a keyword from the typing package and define optional string, but from the Python 3.10 onwards it makes it more easy. We can use the union symbol and define. For example, similarly when you define a call LLM, I can just say system, let's say is of type string or none with the default value of none or whatever. Then we'll go for the various types like a literal, type alias, name tuple and the overall, how they help us to write a better code, what kind of hint they provide to editor, so that editor can highlight the correct, let's say the input during the as you write the code, or using the mypy package it can highlight during the runtime, so you did not wait for compile time error. Okay, so now let's go back to VS Code and we'll go through all these examples so it will be more clear. Okay, so let's start. So I have created a Jupyter Notebook package, and again the Jupyter Notebook, the test file, all I'll upload to TechWebKit website. So you can download the packages from there or the files from there. So let's go through this and we'll try to execute various example and see the type hinting. Right. So again, this one we just went through the example. Whenever let's say we pass different value and we want to run the particular application, only the compile time error it will show, which is let's say editor errors as a red underscore, we see it here, but it does not stop us from running the application. Only when we pass a value which is incompatible at the runtime, like your length check here, then only it will identify that as error. Okay. So now let's move to the next example. So as I talked before, let's say we have this various type, right? We have, let's say, define a chunks as a list of string type, score as a dictionary of string and the float type, or IDs as a tuple of string, any number of strings. So when you say this triple dot means this would be tuple of any number of string. I can pass 2, 3, 4, any number of tuple as a parameter. Okay. Now similarly also we talk about how to use the string union none to define as a nullable string. So now let's say how it makes the life easier, right? So when I pass a value, let's say chunk, so based on list of string type, your VS Code editor can help you if you write something different. For example, let's say if I write a typeset or a dictionary, it will throw back an error saying this is an incompatible type. If you just mouse over, you will say it's expecting list of string, but we are passing a set of string. So it will help us to solve the problem during the runtime instead of waiting for the, sorry, solve the problem during as you write the code instead of waiting for the runtime errors. So now let's say before Python 3.9, still the type hinting since it's supported from 3.5 onwards, right? But we have to import the package. So you may see some of the code as you come across, some are using some of the modules from the typing package and use this capital letter list, dictionary, tuple, others, and sometimes you may see the value as just the types are by default available in the small letter, let's say list, dictionary, tuple. So both are accurate. It's just that whichever version Python code is there, based on that the source code may have written in that way. If the written source code was initially written in an older version of Python 3.8, then you see some format like this and use the package from the typing package having all the modules. But if you are having a later code which is written after Python 3.9, then you see similar package. Both works in the same way. There is no difference. This is just a convention. By default we don't have to import a new packages in the latest version of Python, so it by default supported in the default Python package. Okay, so now let's look into its next type is called type dictionary and literal type. So what do you mean type dictionary? Let's say when you start writing the AI code, right? We see, let's say OpenAI packages, it accept your input as a dictionary of key value pair. For example, if you see the messages where the role is of type system or let's say user, then you'll pass the message and all those things. We all pass as a dictionary type. But how do we verify whether the dictionary key are correct, or we passing the right values as part of the response request object, right? So that's where a type dict will come handy. So type dict define the particular class as a dictionary class, and then whenever I assign this let's say messages as a list of messages, so that means it will accept a list of dictionary. Now in each of the dictionary we can only provide the key based on the parameter or the attribute that we define in this particular class. So that means in this particular message class I cannot, let's say if I want to pass one more parameter, for example let's say token, so it will give us an error saying this particular token is not a allowed parameter. Since the token is an undefined item type in the message, so it then help us to ensure we pass the right value to the or you structure a dictionary in a way so that we can pass the correct key value pair. Now similarly, literal is used to define, let's say my role is one of the key and it accept a value string type, but what are the allowed string type value? For example, if I go in enum, we can define enum different types, right? But if you go with this simple dictionary of the type string, there is no restriction, you can pass any value. So that's where the literal comes handy. If I define literal of type, let's say user, assistants, or the system, that means role key can accept the value either of user or assistant or system. So that means if I pass a value as a user, this will allow, but if I pass some other value, let's say admin, which is not defined here, it will highlight this as an error. Okay. Okay, so now let's move to the next type of typing, is called type alias, and then it's another one called name tuple. So let's see the type alias, which is very simple type. For example, it's not always easy to or readable to define some type always, right? For example, I want to define something called embedding vector type, and I define this is a type alias of list of float. So that means wherever I want, instead of defining a return type or the typing a list of float, I can just define it as an embed vector. So it makes actually code more readable. For example, I can say average score, and score is of type embedding vector. This is as good as I define it as a type of list and float. Okay, it's almost exactly same way, but type alias makes it more readable. If you have a bigger program, we define all the input types on the top, then it makes life easier as you go, as we understand what are the different types are there. Instead of defining as a list of float, we have given a name. Similarly, for a chart message, instead of defining as a dictionary of string and string, I define the name as a chart message. So then I can define message as type of chart message. So this is what our type alias is there. So next thing is name tuple. Okay, again as a name suggests, right, this is a tuple. Tuple means a set of values similar to list, right, but it's a immutable. So whenever define some class as a name tuple, so that means all the parameter inside can be accessed using the name of the parameter. That means if this is a name tuple, I can just say user dot name, or since it's a internally it is still a tuple, I can just use, let's say, index method, let's say users first element or something like that, right? So this is how that name tuple is useful whenever I want to define a small set of values. And again, if you see the syntax right now, the next thing we talk about, let's say, how does it looks quite similar? How do we define a data class, right? If I go to a data class, we also define in the similar way. We can define, let's say, one class, and we can annotate with a type data type, say annotate with a data class, and then this particular class become data class. Here also you can define some key value keys, and what the and the way we need to access the key also in the similar way. I can create an object of type point data, and point data dot x or dot y we can access. And name tuple also does exactly same way. name tuple also provide x and y, and name tuple, whenever we create an object of the tuple, I can access using x and y. So we need to understand when we should use the name tuple and when we should use the data class. So first distinction is there, right? The data class by default is mutable. That means I can change the value of a data class until unless we define the data class of type frozen equal to true. Only if you define this as a frozen equal to true, then this become immutable. But until unless I define without the frozen parameter, so data class is a mutable. And memory wise is still a class. Underlying data class is a class, so it consume higher memory than to a point tuple or a name tuple, which is internally just a tuple, right? So that's a primary distinction. Usually when you write a code, if you want to store very small value like your address, which is a lat long information, we can define using a point tuple instead of defining them a data class. But let's say you want to define some of the configuration object, which mostly should be immutable, but we may change, or we want to define some method within that particular data class. In that scenario, we have to go with the data class. Okay. The last thing in the type pattern, we will see something called overload. Now let's understand there is a method called fetch user. Now fetch user can accept the value integer union list of integer. So that means the value pass user id can be a integer or can be a list of integer. But if I write a code, how do you define the hinting, right? If I write a code, it can see, if I just go with the C sharp and others, we can define different method overload. In the method overload, we can define different parameters. In the similar way in Python, I can define a method overload. Okay, so that means this is a fetch user method, and these are the overloaded method of the fetch user, but these are not executed during the runtime. So these are only used for the editor to understand what are the different type of parameter it expect. So we can see those type hinting as you type in the code, but these are not compiled. Whenever you run this, either of this fetch user passing a single value or fetch user passing a list of integer, in all case it goes to the fetch user. Now your application code should handle it. So the overload parameters or overload types that we define to a method, these are only for editors, or let's say your any mypy or pyrite packages for do the static analysis. So that's pretty much all about different kind of static analysis or the static typing, and the how to ensure we write a code which can make it easier to understand during the runtime, make it easier for developer also to use our packages. They can know what is different types of parameter is expected, be it a list type, be it integer type, be it a dictionary type. So it makes the code more readable. And as we integrate with the mypy packages during your CI flow, it makes your code compile time or a build time, you can identify the error. We don't have to wait for a runtime error. Right? So now let's go back to VS Code, PowerPoint. So just want to wrap up the session, the key takeaway for today's lesson. So first thing, we always need to remember type hinting is not a runtime behavior. That means if we bypass all the checks, still write the code, it will still try to execute in the runtime. And runtime, if it faces any error because of the mismatched type, it will throw error, but it will not stop us from executing the code. Second thing, the null label type we discussed, the union parameter using the x union none, it will make his life easier instead of defining optional of type, which was introduced in the Python 3.1. So it's not only for none. So maybe if let's say we want to define some parameter as a integer or as a string, or let's say with the multiple different types supported as input, maybe the previous example is always an integer or a list of integer. In those cases, we can use the union operator to define the different type of parameter expected. So then we talk about the built-in generic type, for example, the list, dictionary, which is introduced in Python 3.9 compared to Python 3.8, where you want to import from the typing packages. We also discuss about, let's say, mypy, how to ensure we run our code against the mypy packages. It can identify the error, which we generally use during any continuous integration or build pipelines. And if you are using the editor, we have the pyrite or the pylons in VS Code. They can actually identify, as you type in the code, they can run and identify the possible errors. So Against all of this, there are two key takeaway. First thing, this help us to ensure we provide standard protocol over, let's say, defining your ABC. ABC is the interfaces, right? So you can define a protocol, what are the type of method it's expected, so that I don't have to define interface all the time, and to help us during the doc typing. And the last one is how do we tighten gradually. So also we'll talk about, let's say, when you define your TOML file, we define, let's say, mypy package construct. We define, let's say, some package may be strict would be false, some core packages strict would be, let's say, true. So you can gradually control it. So let's say for the initial phases of the build, we can keep it strict equal to false, and once we reach a certain milestone, we want to ready for the releases, you can change it to strict equal to true, which will help us to catch the errors during the build time. That's all about today's lesson. In the lesson, we'll go through Pydantic package, which actually makes one step more closer to our, let's say, .NET type of programming language. How can we identify during the compile time or the object creation time validation, and why Pydantic become a go-to package for, let's say, any Python programmer, or you write a AI programming or you write an Python services, why Pydantic become a go-to packages, and how it improve your further writing skills. We'll talk about those in the next lesson. Thank you. Everything we covered today, including the scripts, configuration, and extended documentation, is available right now on techwayfit.com. While you are there, check out our deep dives into enterprise security and design principles, or put your skills to test with our developer focused quizzes. Hit subscribe to stay in the loop, and I'll see you in the next lesson.